Hey guys, welcome back to my YouTube channel. Please, I urge you guys to like and subscribe on my video and click the notification button so you get notified anytime I upload a new video. So today we are going to be looking at some questions on differential equation. Basically, this is a past question. Let me just 315/2019/2020. Solve x squared plus 1 dy dx plus 3xy equals 6, and if y and y1 are the solutions of the second order differential equation. I know we have not actually treated second order differential equation, but the video will be coming up very soon. So show that the Wronskian of y1 and y2 is given by Abel's identity c exponential minus a1 over a0 dx. So taking the first question, we say solve x squared plus 1 dy dx plus 3xy equals 6x. So now basically we know that this is basically an ordinary differential equation. Now to know the kind of or type of formula to apply when you come across this kind of equation can be very tricky. So you have to carry out some basic steps. What are those basic steps? Now first we let us try to express this in the standard format for first order differential equation. So what is the standard format? We know that this is a first order differential equation. So what is the standard format for first order equation, which is I naught plus py equals q, where p and q are functions of x, where I prime is equals to the first derivative, like first order derivative. So trying to express this to this will give us a hint on the type of method we are going to apply. So expressing this in this form, we have to eliminate this x squared plus 1, right? So eliminating x squared plus 1 will give me, dividing both sides by x squared plus 1, right? This is x squared plus 1 divided by x squared plus 1 over x squared plus 1. Is that taken? So this will give me dy dx plus 3x over x squared plus 1y equals 6x over x squared plus 1. So you can basically see that this has been expressed in this form, where my p is equals to 3x over x squared plus 1 and my q is equals to 6x over x squared plus 1. So now, writing this in a more standard form, you can write dy dx plus py equals q. So now, if you can recall on the last video we did based on integrating factor method, we said that when we are given this particular form of differential equation, we apply the integrating factor. Basically, this is a linear differential equation. So how are we going to solve or apply the integrating factor method? So first, we have been able to express this in the standard form of first order differential equation, which is a linear differential equation. Then the second step is to get my integrating factor, right? So we all know that my integrating factor is the exponential of the integral of p dx, right? We said my p is 3x over x squared plus 1. So this is basically exponential of integral 3x over x squared plus 1 dx, right? So now integrating my exponential function, this gives me, I can write this as the integral of 3x over x squared plus 1 dx, right? So now taking my constant to the back of my integral sign, this is 3 integral x over x squared plus 1 dx, right? Now let's assume my u is equal to x squared. Take u equal to x squared, then the derivative du dx will give me 2x, right? So making the x subject of formula, my dx is equals to 2u over 2x. So this is basically solving basic integration function. This gives me 3 3 over x over u plus 1, right? Making the x subject to formula, this gives me the u over 2x. Where my x to cancel x, this gives me 3 over 2 integral 1 over u plus 1 du, which gives me 3 over 2, since it's a linear function, 3 over 2 ln u plus 1. So writing it based on my function of x, it gives me 3 over 2 ln x squared plus 1. So taking it back to my integrating factor, this gives me exponential 3 over 2 ln x squared plus 1, right? So this basically is now my integrating factor if. So my second step now is to multiply the given equation, by my integrating factor. So this gives me exponential 3 over 2 ln x squared plus 1 times dy dx, right? Plus exponential 3 over 2 ln x squared plus 1 times 3x over x squared plus 1 y equals exponential 3 over 2 ln x squared plus 1 times 6x over x squared plus 1. So, like we said, based on our last video of integrating factor method, we only take my dependent variable and my integrating factor. That is the only way to reduce the left hand side of my equation, which is this. So basically taking my dependent variable and my integrating factor, this can also be written as the derivative of y times my integrating factor, which is exponential 3 over 2 then x squared plus 1, then equal to my right hand side, which is exponential 3 over 2 ln x squared plus 1 times 6x over x squared plus 1. Is that taken? So we move on. So this can, let me write this in a more clear term. This is y times exponential 3 over 2 ln x squared plus 1 equals exponential 3 over 2 ln x squared plus 1 times 6x over x squared plus 1. So integrating both sides, this is integral of this and integral of this, give me y, because this cancel out, this y times exponential 3 over 2 ln x squared plus 1 equals integral of exponential 3 over 2 ln x squared plus 1 times 6x over x squared plus 1 dx. Now, we all know that it's a standard formula that says the exponential of ln f is equal to what? F. So basically, we are given our integrating factor to be the exponential of 3 over 2 ln x squared plus 1. So basically, writing this as exponential ln x squared plus 1 3 over 2, right? This is my rule of logarithm. So the exponential of ln f gives me, that's my f can be taken as x squared plus 1 raised to the power 3 over 2 will give me x squared plus 1 raised to the power 3 over 2. So writing, we have exponential 3, exponential 3 ln x squared plus 1 y, right? Which gives me the integral of exponential 3 over 2 ln x squared plus 1 times 6x over x squared plus 1 dx. So like what we proved based on our last, we said exponential of ln f is equal to f. So exponential of 3 over 2 ln x squared plus 1 can be written as x squared plus 1 raised to the power 3 over 2, right? Equals integral, this can be written as x squared plus 1 raised to the power 3 over 2 times 6x over x squared plus 1 that taken. So now to integrate my right hand side, I can say let u be equal to x squared plus 1. So the x gives me 2x, and making the x subject to formula, this is the u over 2x. So substituting it in this my left hand side equation, or my right hand side equation, gives me integral u raised to the power 3 over 2 times 6x over u dx, right? And my dx can be written as integral u raised to the power 3 over 2 times 6x over u times du over 2x. This cancels this. 2 into 1. Don't forget my 3 over 2 here. There's a 3 over 2 here from my integrating factor. Sorry. There's not 3 over 2. So you're on the right track. So x will cancel x, right? So 2 into 1. 2 into 6 is what? 3, right? So this gives me 3 integral u 3 over 2 over u du. Now 3 over 2 u du, that's 3 over 2 minus u. Apply my logarithm or indices. This gives me 3 integral u 3 over 2 minus 1 du, right? Then 3 over 2 minus 1 gives me equals 3 integral u raised to the power 1 over 2. Am I right? So apply my du. So now we're going to integrate this because we have gotten a more simpler term to integrate. So integrating this function with respect to u gives me 3u 1 over 2 plus 1 over 1 over 2 plus 1 plus c, right? So this gives me 3u raised to the power 3 over 2 over 3 over 2 plus c. Gives me 3u raised to the power 3 over 2 times 2 over 3, 3 cancel 3, plus c. So this gives me 2u raised to the power 3 over 2 plus c, where my u, we assumed it to be what? X squared plus 1, 2x squared plus 1 raised to the power 3 over 2 plus c. Taking this, bringing what we have here, we have y times x squared plus 1 raised to the power 3 over 2. Now dividing both sides by x squared plus 1 raised to the power 3 over 2 gives me, we have x squared plus 1 raised to the power 3 over 2, x squared plus 1 raised to the power 3 over 2, x squared plus 1 raised to the power 3 over 2. Then this gives me my final equation to be 2 plus c over x squared plus 1 raised to the power 3 over 2. Then there I have my solution. So is that understood? So now we go to our second question.